So here we're given the three circles, and their centers are on this line segment PQ, and their tangent at points P, R, and Q to this larger circle, where R is also in PQ. And the question is, how do the circumference of the larger circle compare to those of the sum of the two smaller circles? So the first thing to recognize here is that the center of that larger circle has to fall on this line PQ. It has to be somewhere, let's say here. And the way you can think about this is that if I were to draw any other two circles that were tangent, something like this, and if I were to connect them to where this is tangent, you would notice that this wouldn't be a straight line. And so I'm trying to exclude the scenario because I have to ultimately relate the radius of the larger circle to those of the two smaller ones. And that's why I wanted to show that that's the only way that's going to happen, is that if the center of the large circle falls on the line segment PQ. So I'm going to call the radius of the this circle R1. I noted the center here. This is R1, R2, R2. So quantity B, which is the sum of the circumference of the two smaller circles, would be 2 pi R1 plus 2 pi R2. Now the diameter, which is the length of line segment PQ, would be 2R1 plus 2R2. These two added, all of them. Which means that the radius of this larger circle would be half of that, or R1 plus R2, which means quantity A is 2 pi times R1 plus R2, which is exactly equal to that. Because if you distribute the 2 pi, you get the same expression. So the two quantities are equal, and the answer is C.